Good afternoon and a warm welcome to all the viewers and participants joining us on Massa University Facebook page and YouTube channel. We are delighted to have you here for the webinar series hosted by the Faculty of Engineering, Bioenvironment and Information Technology at Massa University. Today, we will be hearing a presentation from Dr. Umi Kalsum binti Muhammad Yusof. I'm Siti Madiha binti Mazlan and I am honored to be your moderator for today's session. Dr. Umi Kalsum earned her PhD in Biomedical Engineering from University Putra Malaysia, focusing on classifying myoproliferative nucleus using deep learning technique. She completed a data star program, data scientist track certified by ASEAN Data Analytic Exchange, ADEX, and Malaysia Digital Economic Corporation, MDEC. She working as an experienced data scientist in various industries, including healthcare, telecommunication, infrastructure, solution, and property. She has received notable awards, include the Outstanding Award by Youth Agenda. Without further ado, I would like to welcome Dr. Umir Kassom, who will be speaking to us with topic Unlocking Insight, Navigating the Data Landscape in Biomedical Engineering. Alright, Dr. Umir Kassom, the floor is yours.
Thank you, Madiha. Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. So, as mentioned by Madiha, I'm Umi Kasum. Currently I'm working as a data scientist in industry and also my PhD in biomedical engineering. So, for me, today's session is more towards sharing session. It's not really academic session. Good. Okay, so we proceed to the first slide, which is the outline of my sharing session today. So we'll go through what is data analytics, and then we go to what is the key components of data analytics, and then what is the type of data analytics, and also the real world application. And then we will see who is behind the scene of data analytics, and also we see what is the challenge in implementation of data analytics, and the future direction of data analytics in biomedical engineering, and finally the conclusion of today's sharing. Okay, first, what are the data? So we go to the basic. What are the data? So according to the Oxford Learner's Dictionary, data are facts or information, especially when examined and used to find out things or to make decisions. And bear in mind, data is not necessarily true. So we need to analyze it to find what is, we need to analyze it, not just take as is. Okay. So this is a type of data in biomedical or in healthcare. So we have multiple types of data and it actually coming from multimodalities. So the data is actually coming from electronic health records. It's actually from a data streaming from the health wearables, and also coming from maybe insurance, health claims, pharmacy data. We have the clinical trials and even genomic registries, and definitely from medical imaging, example like MRI, CT scan. Okay, so in more advanced analytic in machine learning, so sometimes we need to combine these types of data to have more precise outcome. Okay. So what is data analytics? So data analytics is the process of examining and interpreting raw data to extract meaningful insight, to discover patterns and make informed decisions. It involves the use of various techniques, tools and methodology to analyze data. And all this data actually is coming from diverse sources, such as database, spreadsheets, logs, and more. Okay. Next, we go to the key components of data analytics. So in here, I list out 5 components of data analytics. So first, we have data collection. So as I've mentioned just now, we have multimodal equipment in hospital. Example, we have data coming from imaging. We can have data coming from a wearable device. So all of this equipment will collect the data and store in a database. So after we have data collected in the database, we will have a data cleaning. As I've mentioned just now, data not necessarily true and data is not necessarily clean. So we need to have data cleaning as, maybe you have heard the concept of GIGO, garbage in, garbage out. So if you analyze the data that is not clean, so the output maybe will produce not accurate result. So we need to have a data cleaning. And next, after we have a data that already clean and we have flat data already suitable for analysis, so we will have a data analysis component. So we will, in this stage, so maybe we will develop a machine learning, or maybe we will analyze using a statistical formula and everything to find what is actually happened in that data. And finally, we also we visualize the data using BI tools to see the pattern, to see the trend, or maybe we want to present it to the user to convey the information hold in that data that we have collected before. And finally, we have interpretation, which is from the data, we can decide what is action to be taken or action taken from the data that we have. Okay, next, this is types of data analytics. To summarize, actually, type of data analytics has 4 types. So first, we have descriptive analytics, and then we have diagnostic analytics, we have predictive analytics, and we have prescriptive analytics. So for descriptive analytics, it's actually, or it's simply we want to see what happened from the data. And then for diagnostic analytics, we want to know why did it happen. And then for predictive, we want to predict what will happen in future, for example. And then for prescriptive, we want to see how we can make it happen. And for the level of complexity, descriptive is actually more simple, and for the prescriptive is more complex analytics actually. And we in I can say in analytics project, not necessarily we will complete all the analytics. Sometimes we just do for descriptive and diagnostic only. Just what we want to see, or we want to know what happened. And if for the more mature data, we can go up to prescriptive analytics. Okay. Oh, I think the setting is a bit haywire, but hopefully still can be read. Okay, for descriptive analytics, so I will go in details more what is descriptive analytics. Example, we want to summarize and visualize large biomedical data sets. So from the data set, we want to see the patient demographic, and we want to see the historical disease prevalence. Just that, it's nothing more. Just simply we want to describe what happened in our data set. And then moving forward, we go to diagnostic analytics. We want to identify the causes of what's happening. So we want to understand, example, why certain treatment are more effective in specific population and it's not effective in other population. So we diagnose the data to know why is this happen. And then as we move forward, we will have predictive analytics. So it started to have more advanced analytics, which involve statistical algorithm, and also we have machine learning model. So example, we have predictive modeling, which is can be used to anticipate disease progression. Okay, Madi, the word is not the word is just half appear in here. Maybe I can present using share screen.
Yeah, can.
Oh, you can. Okay. Share screen. Okay. Window here. Here. Okay. Can you see it clearly? The slide? Madi. Yeah, can you see the slide here? Okay. All right. So, okay. So, for predictive, maybe we can use full screen. Okay. So, in prescriptive, oh, sorry, yeah, I have explained about predictive analytics. So, to go to the prescriptive analytics, in this stage, we can recommend specific action or intervention. And also in this stage, we may apply machine learning and we can generate recommendation for the most effective and well-tolerated medication and dosage based on patient unique characteristic and historical data. Okay, we go to the what is the real world application. So there is a lot of real world application and it's very advanced and very fantastic. You will feel amazed when you know how actually they develop this application. But I just pick four just for sharing for this session. So first we have detecting cardiovascular disease, and then we have sepsis detection, we have skin checking apps, and also we have drug discovery. Okay, to go in details, what is detecting cardiovascular disease application about? So, cardiovascular disease are the leading cause of death globally, taking an estimated 17.9 million lives each year. So, the American Heart Association estimate up to 90% of cardiovascular disease may be preventable with education and action. So, this company, namely as a life core, they developed a digital health devices called Cardia Mobile. So this device is machine learning powered ECG sensor that deliver medical grade heart data on the go. So it helps patient to access, manage and share the data and connect with cardiologists to better understand and manage their heart health. So this is how the device looks like. So it's connected to your mobile phone, and this is the device. So you just put your finger on the device and you will have ECG reading here. So it can, I mean, when your cardiologists have a real-time monitoring ECG, so it can prevent the cardiovascular disease happen to you. So it's very useful to the person that have like high risk people. Okay, next is sepsis detection. So what is sepsis? Sepsis is an overwhelming infection that can lead to total body failure. So HSA Healthcare, which is healthcare provider in US and UK, they developed a predictive algorithm called sepsis prediction and optimization of therapy, or SPOT. So they apply techniques of machine learning and AI to enhance clinical effectiveness by continuously monitor patient data to identify potentially impending sepsis case. So the amazing things is actually the algorithm able to detect sepsis 6 hours earlier than the clinician and enabling healthcare system to cut sepsis mortality rates by nearly 30%. It's very high. And actually this algorithm has been used with 2.5 million patients and helped save an estimated 8,000 lives in the last 5 years. So it's already been used in real life. So, you know, it saved 8,000 lives. really amazing. Next is skin checking apps. So it allow user to take pictures of their suspicion skin lesions and upload the images and analyze by AI algorithm. So this technology help detect skin changes that may lead to skin cancer. So I have checked these apps actually. It's available in Apple and Android. So example of this app is Mi Skin. So this app allow the user to compare individual moles over time to detect changes. The second one is Mole Mapper, guide physicians to help monitor suspicion lesion without monthly in-person visits. So we can just do examination or monitor your skin lesion just at home. And then Skin Check, it allows users to do a complete skin cancer exam and track changes over time. So this app provide helpful advice on how to perform a skin exam. So even though all this examination can be done at home, but still need a dermatologist to confirm the diagnosis. And for the first app is paid app, but the second and third is free, so you can download it from the Apple Store and your Android. Okay, the next one is drug
Let
discovery.
me.
Yeah.
Okay. Is it you move the slide?
Yes. The move slot.
Because the slide is not move.
The
Okay,
slide's
okay,
not
okay. Now,
moving.
okay.
Okay.
No.
Okay.
Okay. You can try.
Um.
Ada macam gerak not move.
Since when actually
Macam
the
homing.
slide is not moving? Okay.
It's okay
Let
lah.
me
Okay, okay. Try.
let me
Okay.
stop sharing here. Let me try.
Password dia.
Okay. Can you help me to share the slide? Okay.
Jadi slide yang
Um,
predictive. Okay, this one move. Yeah. Okay.
okay. Okay. Okay. For drug
Well,
discovery, is it okay?
yeah, can. Okay.
Okay. So, for drug discovery, the development of drug made from protein has traveling crunch point where fewer than 10% of such drug candidates success in clinical trials, meaning that for the development of drug made from protein, less than 10% success in clinical trial. So it's very less. So failure at this late stage of development costs between US dollar 30 million to 310 million per clinical trial. So potentially costing billions of dollars per drug and waste year of research while patient wait for treatment. So advancement in machine learning program by this company called DeepMind. So it has revealed 200 million proteins. So this actually can really help and speed up the search for new medicine. So this ability to quickly see a protein structure is valuable for scientists seeking to cure disease because it gives them a completely detailed looks at the protein that underpin all biological process. So this protein predictive machine learning developed by DeepMind, it helped for drug discovery. Okay, so who is behind the scene of data analytics? It's a lot. So we have data scientists, we have data architect, data analyst, AI engineer, statistician, and definitely a domain, or I can say domain knowledge from the medical practitioner example. So I just want to cover these three, which I can say this is the most basic role in data analytics. So we have data engineer, we have data analyst, and we have data scientist. So who is data engineer? So data engineer, actually this person built and optimized the system that allow data scientists and data analysts to perform their work. Simply said, data engineer is actually a data supplier. So this person will maintain database. All the data that we collect, so we store in database. So this person maintain. So the data scientist and data analyst can extract the data from the database. So the requirement to become data engineer, this person must have strong programming skills. This person must know cloud computing technologies and also must know a knowledge about big data. So the specific tech stack that this person must know SQL query, and then Python coding, and then cloud example for server, and then for storage, database in cloud, and also related to distributed computing. And then we move forward to data analyst. Who is data analyst? So data analyst, this person deliver value by analyzing data and communicating the result to help make business decision. So data analysts will extract the data, and usually they will provide a dashboard. So this dashboard usually covers for descriptive analytics as well as diagnostic analysis. So it will, the dashboard will describe what happened and then why this happened. Okay, so what is the requirement to become a data analyst? So you must have a communication skills, and then definitely business savvy or domain knowledge, because you need to know why this happened. So you need to have the domain knowledge. So this person must know SQL, and then business intelligence tools or BI tools, example Power BI or Tableau. And then they need to know Python and also R for analysis. Okay, move forward. We go to data scientist. So who is data scientist? So data scientist, this person use data to solve business problem. So this person usually involved in predictive analytics as well as prescriptive analytics. So the requirement to become data scientist, this person must know statistics, mathematics, and then programming skills, big data, and I would like to add this one, same as data analyst actually for domain knowledge. Must have a domain knowledge for that particular problem that they want to solve. So the tech stack is almost similar actually like data analyst. They must know the SQL, Python, R, and also cloud, because sometimes for big data, we cannot analyze or we cannot develop machine learning in our local PC. Sometimes we need to use a cloud as a software. I mean, we need to like create a model in cloud, and also sometimes we need a HPC, high performance computer, to create a machine learning model and also deploy the model. Okay. Next, we see what is the challenges for data analytics specifically in biomedical engineering. First, it's about heterogeneity of the data source. So biomedical data come from diverse sources such as EHR, medical imaging, genomics, wearable device, etc. So to integrate and harmonizing this data is significant challenge. So it requires standardized format and interoperability to derive meaningful insight. So for example, actual case for my project actually, as my previous experience to develop a model, a machine learning model, just using image data set, example, just using histopathology image. But then when I move forward to another project, they required me to combine like the text data or numerical data together with the imaging. So this requirement actually needs more advanced technique to combine this multimodality or to fusion the data. So this is the challenge. Okay. Next, volume, velocity, and variety of data. So this is actually the characteristic of big data. So the sheer volume of healthcare data coupled with its rapid generation. So examples coming from IoT, it can be 1 million rows of data within, like couple of days. It's very huge data and very fast coming, and it's diverse format. So maybe it's from numerical data and coming from text and then image. So it can overwhelm traditional analytics approach. Scalable and efficient analytics solution are needed to handle large dataset and real-time streaming data, ensuring timely and accurate analysis. Okay, yeah, I provide 6 challenges here. So this is the third one, data privacy and security. So biomedical data often contain sensitive and personally identifiable information. So ensuring robust data privacy and security measures is critical to comply with regulation, for example, with HIPAA, and to maintain patient trust. Number 4 challenge is to interpretable and explainable model. So biomedical decision based on analytics must be interpretable and explainable to gain acceptance from healthcare professional and regulator. So I think maybe you have heard machine learning model is black box. So this black box is may hinder adoption, and there is a need for transparent algorithm that provide insight into decision making processes. So example for doctor, they don't really understand how this machine learning produce the output, or how actually this, what is behind of this machine learning, how this machine learning can classify this disease. So the doctor will not have, they cannot put trust on this machine learning model. So we need to have interpretable and explainable model so that easy for the doctor to make decision making process in future. So validation and clinical adoption. So it related to my previous point. So bridging the gap between research and clinical adoption requires robust validation process, stakeholder engagement, and addressing practical implementation challenge. So when they already understand what is machine learning, so they have the mindset, so they can understand how this machine learning works. So it can bridge the gap. So it's not, we have a lot of research, thousand of research, but we cannot really implement in real world because the example here is medical practitioner, that the actual person use the model, they cannot understand, so they will not use the model. So the model is just left out like that. Okay. So that is the challenge for validation and clinical adoption. And finally, regulatory compliance. So to navigating complex regulatory environments, such as those outlined by the FDA, poses a challenge for development and deployment of data analytics solution and biomedical engineering. So it's really time consuming. Even to have ethics approval, it may take a year. So to comply with all the regulatory, yeah, it's a huge effort, but still we need to follow it. And yeah, that's why it become a challenge for that. Okay, next we will see what is the future direction of data analytics in biomedical engineering. So as I mentioned, we have multi-modalities of data from the multimodal equipment. So the future direction is how to combine, or how to have a data fusion, and we can produce a precise model or precise algorithm. So fusion of heterogeneous data types, example from the genomics, imaging, and EHR, to extract comprehensive insight and leading to more accurate diagnosis, personalized treatment, and predictive model. Okay, the second one is integration of digital twins. So this is quite interesting actually. So what is digital twin? So digital twin, it's creating a digital replicas of biological systems, organs, or even individual patients. So researcher can stimulate various scenario so they can predict outcome and personalize treatment strategy. Okay, for example, we have organ transplant. So we can make use of these digital twins to simulate first. We do the organ transplant, we simulate it, so we can see what is the possibilities of the complication. So maybe we can avoid it. So after we identify all the complication, we can avoid it. Then we implement in actual organ transplant. So it's very interesting for digital twins technology. So the third one is advancement in predictive analytics. So to empower healthcare provider to intervene early and then to tailor intervention and improve patient outcomes. Yeah, we already have the predictive analytics, but we need to advance it to have a more precise predictive analytics. Okay. And finally, we have a real-time monitoring and feedback system. So we already have the wearable device, and we already have the biosensor, and we have IoT technology. Sometimes it's silo, or maybe the data we just keep it by ourselves. So in future, we can combine all this data and technology. So healthcare provider can continuously monitor patient health status, detect anomalies, and intervene promptly, and finally enhance overall healthcare delivery. Okay. Yeah. Finally, we have a conclusion here. So, data analytics serves as a powerful tool that involves the systematic analysis of data to derive valuable insight and facilitate informed decision making. So, as we navigate the dynamic landscape of data analytics, addressing challenge and embracing future innovation will be pivotal in unlocking its full potential in biomedical engineering. Okay. So, yeah, if we have question. I think you are mute, Nadia.
Okay, thank you, Dr. Omi, for your insightful
Welcome.
presentation. Very interesting lah. Okay, because I would like to ask you. Okay, is okay, what the application lah? What between the data analytic and then the new technology AI, artificial intelligence? What the relationship between data
Yeah,
analytic and AI? Then we can
AI.
implement in the medical engineering.
Okay. Actually, AI is a big umbrella, and then, for example, for data analytics is intersection, or we can say it's under the umbrella. So we need data analytics. Example, for data analytics, we need to have historical data. Example, because why we need historical data? Because we want to predict. So before predict, we need to know what is the previous trend of the subject or the problem. So for AI itself, sometimes it need this predictive. Example, for the predictive of a protein structure just now. So sometimes they need that previous or this predictive to move forward for application in AI. So sometimes AI don't need historical data. They can learn from data itself. I mean, from the data on the go, they can move forward. Example, for the robot, they don't need historical data. They can just they can just move forward with the existing or the real time data feed to them. Okay. Yep.
Okay, thank you for your clear explanation, Dr. Umi. Okay, can we conclude now? Okay,
Yes.
as we conclude today's session, I want to express our gratitude for your insightful presentation on the unlocking insight, navigation, the data landscape in biomedical engineering. Your expertise has certainly added value to our understanding in this important topic. On behalf of Masa University, I would like to thank to all the participants for joining us today. Hopefully, the presentation was beneficial for everyone. For all audience and viewers, we are invite you to explore more about our program, especially in the Faculty of Engineering, Built Environment and IT, and join us on our open day. Details can be found on our website. Once again, thank you, Dr. Umi, for your time,
Welcome.
engagement, session. Okay, goodbye, everyone, and we look forward to having you with us again in our future webinar session. Okay, thank you so much.
Welcome.